Hi everyone, welcome back to another video. Today we will be solving two questions. The first question is removing duplicates from a sorted linked list, and the second problem is slightly harder version of this problem, which is removing duplicates from sorted list too. So in the first problem, we have to remove all the duplicates such that each node appears only once. So for example, if we have duplicate nodes with value 1, we have to keep at least one node, and in the second problem, we have to remove all the nodes. So for example, this node 3, there are two nodes with node 3, and in the final linked list there is no node with value 3, so we have to remove all the nodes with value 3. And in our first problem, we have to keep at least one node even if it is duplicate. So in this problem, it is important to understand the patterns in this easy and the medium version. In this easy problem, let's say we have our linked list 1, 1 and 2. So the final linked list is going to be 1 and then 2. So as you can see, the original head of this linked list is not going to change. So in our function that we have to implement, so if we just return head here, so this head would be our final answer. The only thing is we have to just modify our linked list and remove the duplicate nodes and just keep one duplicate node. And if there are no duplicates, then we don't change them anyway. And if you just draw diagrams, you will understand that the head of our linked list, it does not change. And in our second problem, if let's say the duplicate nodes, it starts from the head, then as you can see, this node 1 is not in our output linked list, and the head of our new linked list, it starts from node 2. So that's the pattern that we have to recognize in both the problems, that in this medium problem the head is going to change, and in this easy problem the head is not going to change. That is why we can simply return head at the end after modifying our linked list. So if we think about this problem, so we just have to simply iterate over this linked list first. So let's try to solve it in constant space and O of n time. For O of n time, we can try iterating over our linked list and modify the pointers. So let's try to do that. So initially what I can do is I can create a current pointer and I can initialize it to head. And for iterating over our linked list, we will need to create a while loop, and inside of it I need to have condition while current is not equal to null. And inside our while loop I can create a next node, which is going to be current dot next. So if you try to just draw some diagrams, so initially current would be this one, next would be this one, and initially current dot value and next dot value, they are equal to each other. So if let's say there are multiple nodes with value 1, so what we have to do is initially current is here and next is here, and as long as both of them are equal, we can simply move our next pointer till we reach a node where current dot value is not equal to next dot value. If we reach 2 here, then what we can do is we can update current dot next equal to next. So this way we can simply update one dot next here and point it to node 2, and this way we can get rid of these duplicate nodes. So let's try to write that. So inside here what we can do, can check while next is not equal to null and current dot val equal to next dot val. Then we have to keep incrementing our next pointer, and once we are done with this while loop, what we have to do is we have to update current dot next equal to next, and at the end we have to update current equal to next. And in the case when in our inner while loop next becomes equal to null, we are simply setting current dot next equal to null and setting current equal to null here, and when current becomes null, we will be done with this while loop, and at the end we are simply returning our head. So let's try to run it. And yeah, that works, and let's try to submit. And yeah, that works as well, which is great. And now let's have a look at our second problem. So for our second problem, we have to get rid of all the duplicate nodes. So here, as you can see, that the head of our linked list is going to change. So this problem follows the pattern of using a dummy node. So let's try to initialize a dummy node here. Dummy new list node -1, and initially we have to set dummy dot next equal to head, and we have to create a previous and set it to dummy, and we can create current pointer and set it as head. And at the end, we have to return dummy.next. So this problem follows the pattern of updating previous pointers. So initially, when we have 1, 1, 1, 2, 3, our dummy node would be here, -1. And we have to get rid of all these 3 nodes. So we will have to update previous.next equal to this node 2 here. To avoid null pointer exceptions, we are setting previous equal to dummy instead of setting previous equal to null. We could also do previous equal to null and not use dummy nodes, but it would just give us headaches with checking for null pointers. So it's better to use a dummy node. So let's try to write our while loop. So in our while loop, current is not equal to null. And also for our case, when there is only one node in our linked list, or when the head is null, we can simply return head. Inside of our while loop, we can create a next pointer and assign it current.next. And now we're going to check current.value and next.value. So if current.val is not equal to next.val, then what we can do is we can simply update our previous equal to current and current equal to next. And in case they are equal, then we have to keep going till we find a node where current.value is not equal to next.value. So for that, we can write another inner while loop, and we can check next is not equal to null and current.val equal to next.val, and update next equal to next.next. And once we reach a node where current.value is not equal to next.value or next becomes null, then we have to assign previous.next equal to next and update our current equal to next, because it could happen that there are more nodes with value 2 here. So that is why we update current equal to next and keep our previous pointer as it is. So after that, we have to set previous.next equal to next and update our current equal to next. And this way we will remove all the duplicate nodes. So let's try to run it. Wait, before running this, we have to check one more thing. So here I am assigning next equal to current.next. So what happens if next is equal to null? So if next is equal to null, then next.val is going to throw a null pointer exception, and we have to check current.next is not equal to null, because for the case when current.next is null initially, when current is head, then we know we can simply return head, and dummy.next would simply return head if there is only one node in the linked list or head is null. So we just need to add this check to prevent null pointer exceptions here and cover the cases for greater than equal to 2 nodes in the linked list. So this whole while loop is for the case when there are greater than equal to 2 nodes in the linked list, and when there are less than 2 nodes in the linked list, we can simply return dummy.next. So now let's try to run it. And yeah, that works. And let's try to submit. And yeah, that works as well, which is great. So I hope this made sense. If you have any doubts, let me know in the comments. This problem would be simple if you try to draw diagrams and try to understand the patterns of dummy nodes, and understanding that the head is being changed for this medium problem and the head is not being changed for the easy problem. And another variation for this problem could be that we have to remove duplicates from an unsorted list. So if the list is unsorted, then we can use a hash map to store the mappings and map the node values to the counts of the number of nodes we have in our linked list, and using extra space and 2 iterations, we can solve that easily. So I hope this made sense, and if you have any doubts, let me know in the comments, and I'll see you in the next one. Thanks for watching.